Thank you for watching my top 3 Newton laws of all time. Number 1. Newton's first law. This law states that an object at rest will stay at rest and an object in motion will stay in motion unless acted on by an external force. As you can see here, this constant velocity car is moving at a constant rate until it runs into the wall. The wall is applying a force onto the car, which causes it to both change in speed and direction. Next up, we've got Newton's second law, which states that force is equal to mass times acceleration. This means that as long as the net force stays the same, then mass and acceleration have an inverse relationship. It also means that there is a direct relationship between net force and mass times acceleration. If mass or acceleration go up, force will, and vice versa. To demonstrate this relationship, we tested how mass and force influenced acceleration. We did 3 experiments, one being the control and the other 2 testing how an increase in force with the same mass means that there is an increase in acceleration, and how an increase in mass with the same force leads to a slower acceleration. Instead of measuring the acceleration, we measured velocity, because the only significant force acting on the carts was gravity, which we already know is constantly accelerating. This means that if the cart has a higher velocity over the same distance, it must also have a higher acceleration. We did this by placing a timer down and recording the cart move, which allowed us to test the time it took for the cart to travel 0.575 meters. For our control, our data looked like this, which averaged out to a velocity of 0.65 meters per second. For the experiment where we added force, our data looked like this. As you can see, the cart moved at a much faster rate, which gave us an average velocity of 0.86 meters per second. For the experiment where we added mass to the cart but kept the force the same, the average velocity was 0.383 meters per second, meaning that there is an inverse relationship between mass and acceleration. Finally, we've got Newton's third law, which states that for every action there is an equal and opposite reaction. It states that if you smack your hand into a rock, you might break the rock, but it also hurts your hand too. Here, we have a pool ball that is getting hit by another pool ball. If you look closely, when the first pool ball collides with the second, it exerts a force putting the second ball into motion, but an equal force is exerted onto the first ball, causing it to come to a complete stop momentarily until it is hit again. We also have on here some air hockey pucks that bump into each other, exerting a force to both which slows one and speeds up another. And now it is time for the challenge round coming up, also done with pool balls. Now it goes pretty fast, so we have the video in here 3 times in slow motion to demonstrate every law. The first law shows that the pool balls will stay at rest until something comes and smacks them. Pay attention to the orange ball for the next 2 laws. When it collides with the red striped ball, it hits it with a smaller force than the cue, so the acceleration is lower. For the third law, the orange ball smacks into the table immediately, but the table exerts an equal force onto the ball, so it bounces off. That's all for my Newton's top 3 laws. Thank you for listening.